Okay, so problem number one. You had 5 over radical 18. So remember, when you're simplifying your fractions with radicals, it's not just about reducing if you can reduce. If there's a perfect square inside the radical, got to take that out first. So, well, you don't have to. You could wait to the very end and do it, but it's easier if you take them out in the beginning because it keeps everything smaller. So the perfect square inside here, this is 9 times 2. So the perfect square is the 9. So this is going to give you 5 over. This is going to come out as a 3, and that stays inside the radical. All right. So after taking out the perfect square, I still have a radical in my denominator. So now I have to multiply top and bottom by whatever the radical is. So times radical 2 times radical 2. So 5 times radical 2 is just 5 radical 2. Radical 2 times radical 2 is just 2. 2 times 3 makes 6. So I'm going to get 5 radical 2 over 6. Let's go on to the next one, number 2. So this one you had 8 over radical 24. All right, so remember, you can't reduce the 8 and 24. The rule again, inside with inside, outside with outside. So can't reduce these two numbers. But check to see, is there a perfect square inside the 24? Yes, there is. Remember, this is 4 times 6. 4 is my perfect square. So this guy can come out as a 2. So you're going to end up with 8 over 2 radical 6. After that, if you want, you could reduce the 8 and the 2 right now. That's fine. That's going to give you 4 over radical 6. And then for my next step, since I still have a radical in my denominator, I got to multiply top and bottom by radical 6. So on the top, I'll get 4 radical 6. On the bottom, radical 6 times radical 6 is just 6. And now the 4 and the 6 could reduce again. So this is going to give me 2 radical 6 over 3. So that should be your final answer right there. Next one, number 3. If I have 18 over 15 radical 27. All right. So I'd start by reducing the outsides first. These can both be divided by 3, so that's going to be 6 over 5 radical 27. From there, I have a perfect square inside my 27. This could be 9 times 3. So I can take out the 9. The 9 comes out as a 3, which has to multiply with this, making 15 on the outside. And a 3 left over on the inside still. And I got the 6 on top. We could reduce again really quick, the 6 and the 15. So this is going to make 2 over 5 radical 3. After that, since I still have a radical in my denominator, I'm going to have to multiply top and bottom by radical 3. So now 2 radical 3 is what you get on the top. On the bottom, radical 3 and radical 3 is just 3. 3 times 5 makes 15. So you should get 2 radical 3 over 15. Last one, or at least the last one of the division of radicals. We got 20 radical 6 over 25 radical 80. So again, start by reducing outside with outside, inside with inside. 20 and 25 will go down to 4 and 5. And then these can both be divided by 2, making radical 3 over radical 40. From here, there is a perfect square inside my radical here, so we're going to take that out. This could be 4 times 10. So the perfect square is the 4. This comes out as a 2. So since this comes out as a 2, it's going to multiply with the 5 to make a 10. So I'm going to get 10 on the outside, and I still have a 10 left over on the inside. And then on top, 4 radical 3. I could go ahead and reduce the 4 and the 10, so this is gonna be 2 radical 3 over 5 radical 10. And now, since I still have a radical in my denominator, I will multiply top and bottom by radical 10. Times radical 10 times radical 10. On the top, 3 times 10 is gonna make 30, so I'm gonna get 2 radical 30. On the bottom, radical 10 and radical 10, that's just 10. 10 times 5 makes 50. And I can still reduce one more time. 2 and 50 can both be divided by 2. So my final answer is just going to be radical 30 divided by 25. We're on to number 5. Addition and subtraction of radicals. So for number 5, we have 2 radical 16 plus 5 radical 9. So we can only add radicals again if the radicals are the same. Here they're not. This is radical 16, this is radical 9. I can't add them together. But let's simplify them first. We should recognize by now when the number inside the radical is a perfect square. 16 is a perfect square. Square root of 16 is just 4. So this is really just 2 times 4. That makes 8. Perfect square also. Square root of 9 is just 3. So this is 5 times 3. Add those together, I get 23. Next one, number 6. So for number 6, I have 3 radical 12 plus 7 radical 3. All right. So again, radicals are not the same, can't add them. But let's try simplifying first. So this radical can be simplified. In this radical here, I do have a perfect square. This is 4 times 3. There's the perfect square of 4. So this guy is going to come out as a 2, and I'll multiply it times the 3 that's out here. So I'm going to get 6 radical 3 plus 7 radical 3. And since now my radicals are the same, now I can add the numbers on the outside. 7 plus 6 plus 7 will make 13. So I'm going to get 13 radical 3. Last one, number 7. So if I have 10 radical 8 times 2 radical 18 plus 4 radical 27. So let's go through, start simplifying our radicals and see which ones we can add, if any. So this one would be 4 and 2. There's my perfect square. This comes out as a 2, multiplies here to make a 20. And I'm still left with the 2 here. This, my perfect square, will be 9. So 9 times 2. That guy comes out as a 3. 3 times 2 makes 6. And then here, my perfect square is 9. This is 9 times 3. This comes out as a 3, multiplies with this to make 12. And I'm left with a 3. So the only ones that can be combined are these two in the front here. So I can do 20 minus 6 to get 14. So I'm going to get 14 radical 2 plus 12 radical 3.